Hi, my name is Spencer Gietzen, and today I'm going to talk to you about IOMs versus IOAs in AWS. First, a little bit about myself. I'm a cloud security researcher at CrowdStrike and previously did pen testing over at Rhino Security Labs. You can find me on Twitter at SpenGeets. Pretty much just tweet about the cloud, so come check it out. First, we're going to talk about IOMs, or indicators of misconfiguration. They're signs of a potentially risky configuration in an environment, essentially. They help prevent bad guys. Some examples of indicators of misconfiguration are like public AWS S3 bucket, that could be data exfiltration, overly permissive policy applied to a user, that could be privilege escalation, an IAM role trusts an unknown principal, that could be some actor establishing persistence. A lot of different things that this could be. The reason they're indicators instead of just misconfigurations is because they're not always wrong. A public S3 bucket might be supposed to be public. If overly permissive policies applied to a user, maybe they're the administrator of the environment. So you can't just assume things are misconfigurations because they seem risky. It's more of an indicator and needs to be looked into. So discovery of IOMs in an environment, there's a few different ways to do it. You could do it natively in AWS through something like AWS config. There's third-party tools like CSPM tools such as Falcon Horizon by CrowdStrike. There's open source scanning tools as well, such as Scout Suite by NCC Group. So now we're going to dive into IOAs, or indicators of attack, signs that something suspicious is going on. And it helps us detect the bad guys once they're in. Some examples, I always like to start the examples with get caller identity because that's basically the who am I of the cloud, and a lot of attackers do it just to figure out where they landed in an environment, test the credentials, see what the name of my user or role is, etc. So that followed by something like a data exfiltration attempt might look like S3 list buckets. They list out the buckets in the account. And then they use put bucket policy or put bucket ACL to make a bucket public and steal data through that. It could be followed by a spam or a phishing attack through something like simple email service. So you might see SES get send quota across each region in an account to identify regions that are outside of the SES sandbox, meaning that they can send mass amounts of emails, whether that's for spam or phishing or something else. Another example would be a bad IP address. So this could be any API really. It's just that API call coming from a malicious IP address is definitely an indicator there is something going wrong and something suspicious going on. So it's important to kind of check those things out. Discovery of IOAs, it's a lot different than IOMs. Although there are cloud native services like AWS CloudTrail, AWS GuardDuty to monitor logs that might be flowing through CloudTrail and other sources, Amazon EventBridge, just to build your own detections and respond to events and patterns that you might see in an environment that it's not already built into something like GuardDuty. And then there's other open source hunting tools like Trail Scrapers. I have some links to that at the end. But there are not many third-party tools or open source tools that really monitor and take care of this stuff, even though they're just as important or maybe possibly more important than IOMs. But it's hard to say because they tie together so much. For example, I'm going to do a case study on S3 data exfiltration and how the IOMs compare to the IOAs in this situation. So we're going to have an attacker and we're going to have CloudTrail logs of what the attack's doing, essentially. They're going to start off with AWS STS get caller identity. We're going to see a get caller identity log. They're going to run AWS S3 LS. We're going to see a list buckets log. They're going to list objects in a target bucket that they enumerated. We might see S3 list objects, depending on whether or not you have object level logging enabled. AWS S3 API put bucket ACL, and they're applying a public read ACL to make that bucket publicly accessible. We'll see a put bucket ACL log. And then maybe they finish up with AWS S3 sync from the target bucket to a local folder or another S3 bucket to exfiltrate all that data that they have just found. So we might see lots of S3 get objects, lots of S3 head objects, things like that. But again, this relies on object level logging, so it's possible to miss it. So in this scenario, there are both IOMs and IOAs that are applicable. So we will say that the keys got compromised originally through a web application vulnerability. And that's an IOM on its own. Then there's an overly permissive IAM policy applied, which allowed the user to enumerate objects and buckets in S3 and exfiltrate that data all from one account and change the permissions by making it public. Non-existent or overly permissive S3 bucket policy applied, kind of the same as number 2, just on the S3 bucket side. They were able to perform actions that they shouldn't have been able to. And then we'll say S3 object level logging was disabled, so they actually missed out on some of the logs of this pattern or of this IOA. These here are the kinds of things that config, Falcon Horizon, Scout Suite, etc. detect and assist with remediation and findings and all that. But there are also IOAs taking place here. So we're going to assume they're all coming from the same IP address and user agent because this is the same attacker. And all these calls are going to be in a row. So for that entry point, which said it's a server-side request forgery in a web application. So basically they steal the credentials from the EC2 instance metadata service. Following that, they run who am I, figure out who they are and what they can do, or well, not what they can do, but maybe find hints about what they can do in the environment. Then they're going to list all S3 buckets and objects. They made an S3 bucket public, and then they exfiltrated all those objects. And these are things that CloudTrail, GuardDuty, EventBridge, TrailScraper, etc. can help you find and identify. And if they're all coming from the same IP address, each one of these steps from A through E are going to be more risky or something we need to pay more attention to. It's like in SSRF in a web application, exploitation of that is bad news. But exploitation of that plus then the IAM role on the EC2 instance is being used to run get caller identity, that's a little more scary. Then if they're listing S3 buckets in the account and objects in those buckets, that's even more scary. Then they make something public and it gets real scary at that point. And by then they're stealing all your objects. So these kinds of patterns and IOAs can be built up, or the confidence in them can be built up over time by adding steps to the process. But it doesn't mean you need all the steps. Maybe you just have B, C, E. Maybe that's all you see, but that's potentially lower confidence than A through E for the same attack. So you have to build around the patterns and detect what's likely, what's not likely, etc. So here we go, a little just exercise for the viewer, for anyone interested. Do it or not, I won't know. But build an IOA pattern for an AWS attack tool. This tool we're going to use is Paku. It's an open source AWS attack tool by Rhino Security Labs. So what you should do, go to the Paku GitHub, which is linked at the end. Identify one attack module in Paku that you'd like to profile, run it against your environment, check out the CloudTrail logs, see what's unique, see if you can associate those logs with Paku in particular or something like that. Can you identify the next time someone uses Paku against you? Can you tell when these set of actions are scarier than other times? Such as if you can associate them with Paku and you know that Paku is being used, that's much scarier than if you maybe saw the same actions being taken from just a regular user. So this is just something kind of fun, but again, I won't know if you don't do it. So have fun or don't. So thanks for listening, and I wanted to shout out a few different people here. The SANS and KringleCon staff, my team at CrowdStrike, Daniel Greslak, the OG AWS security expert, Cloud Security Forum, Slack, Trailscraper, Scout Suite, and Paku. And check out holidayhackchallenge.com for some fun, and thank you for listening to my presentation.
Ho, 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 ho.